Okay. Hello, Kickstarter. My name is David Cole. I'm the creator for the Hack Your Notebook project on Kickstarter. I'm here with Jeannine Huffman, the co-author for Automate Your Ideas, the Hack Your Notebook booklet number 4 for the micro servo. Little bit about this series. As part of the second half of the campaign, we're talking with all the creators who are involved in this project. There are technically 6 of them, 4 co-authors and 2 designer illustrators. We're going to be talking with each of them as part of the series roundup to let you all get to know them a little bit. And the first one is, we're going to start with the end. It's book number 4, Automate Your Ideas, Jeannine Huffman. So Jeannine, do you want to introduce yourself? And we can talk about how we met and talk about some of the stuff we've done together, share a few photographs, and explain a little bit about the work.
Sure. I'm Jeannine Huffman. I'm an educator, and I teach children and high schoolers and adults. In my effort to try to reduce the costs and make this project affordable for everybody, that's how I ended up designing the Panda robot.
Nice. And so we're going to come all the way back. You know, I used to teach English ages ago. And there was a part of a story where you began at the end, and that's what we've just done. There's a Panda template that's in the booklet, and you've seen it if you've watched the Kickstarter video. And we're going to come all the way back to that. But as a way to begin, Jeannine, I'm going to throw a prompt out to you.
Sure.
It was in the spring of 2014 that Jennifer Dick and myself were at the Tech Museum in San Jose. We were running a paper circuitry workshop with circuit stickers, which had just been released by G-Chi. I think Chibitronics had just formed. They were shipping from their crowdfunding project, and we were at the Tech Museum, and you were there. And then you came up to me, and you were excited about this stuff, and that led to a conversation and ultimately a collaboration. Do you want to explain a little bit about where you were? That we're talking 4 years ago now. The amount of time that's happened, and the relationships with you and others have been really exciting and profound and very motivating.
Yes.
So, you know, briefly, where did that go for you? What was your take with the materials then? Why did they hold your attention? Let's use that as a way to explain where we are now.
Well, you were offering a workshop with G's Chibitronics stickers, and I had seen those, had followed along, looked at G's progress with the different various shapes of the stickers that she was developing. Of course, anybody who sees G's dandelion painting immediately is beyond amazed. And when she peeled back the beautiful artwork, and I saw the circuitry, I had to make it. That's everybody's reaction. I wanted to figure out, how did she do that? I wanted to make my own. In fact, she has since come up with a beautiful little simple template where you can make a dandelion and all of that with sensors. So before that, I was familiar with paper circuits, but not the stickers. And so I came there specifically to learn how to do that. And I kind of noticed, I think in researching coming to the Tech to see you guys and to learn, I saw that you were using an AT Tiny and that Jen Dick had done something. And she actually had that notebook there. So that was exciting for me, and following up on that. Before that, my students had been using the Arduino. Everything I learned from the book that you've seen this one, Making Things Move with Bethany Roberts.
Yeah.
Arduino, she talks about her things that she's created are on the Mars rover. So, and she just talked about how simple it is. It's just parts, you know, servos, sensors, things like that. And so we were making our own robots with Arduino, and I just will show a simple one real quick. That's one of my favorite ones, and it's one of the most beautiful ones. It has the Arduino and a servo in it, but it was expensive. It's too expensive. So the paper circuitry was the vehicle for me, and when I saw the artwork involved with it, with the Tide book, just astonished. And I thought, if I can get my students to understand some simple circuitry and then show them the beautiful part on, you know, here's the circuitry, which I think is beautiful itself, but then they're making something beautiful with it at the same time. That creative process is going to engage them.
Yep.
And as I was talking to you about earlier, I care about students graduating, and the kids I've always worked with, half of them don't graduate. So this was for me, was the Shazam or right. Whatever. Yeah.
Yeah.
So,
yeah. I have a question.
Sure, go ahead.
After we met in 2014, you then started working actually in a notebook. Jennifer and I were really interested in the idea of a notebook because it's a familiar format. It's used for annotation. I'm getting a. Let me see if I can.
Just once I heard it, but yeah, a little bit of feedback.
Yeah. Be back.
Yeah.
Okay. You used a notebook.
Mm-hmm.
You have that nearby?
Yeah, I do.
You begin to iterate and practice and work up templates. Could you show us a little bit about that?
Yeah, sure. Well, the notebook is from your notebook, and at the tech, we brought our own notebooks, and so I brought something, and we did little sketches. Excuse me, and I just had so much fun, and it made me think, okay, I can do this with my students. So the first time I show this to my students, and I show them the simple circuits that go with it, I combined that idea of your notebook with G's series of lessons that take you from one LED to multiple LEDs, and then she did the AT Tiny, but I just couldn't quite figure that out. Wasn't quite ready for that yet. But Jen did it. She did it with the Tide notebook, and so for me, after that wonderful conference, I went right home, made my own little guy, figured out how to program it, and I don't think my first one was with a Spark Fun programmer. I'm one of these our little favorite little guys. I'm pretty sure we tried to do it with our own that we had made. All of the students had made their own because we were trying to, I couldn't afford $20 a student, so or, $2-3 a student, and eventually I broke down, and we all broke down because it has a little USB device, which is just simplifies everything. And I don't have to know how this is made. I just need to know how to use it. So anyways, that was the next step. And then actually hosting a workshop for you was really exciting to do that at the tech. And so I just went from there, but I kept thinking my ultimate goal was to combine the AT Tiny with a servo, so that you could have something moving like a Mars rover, because that's the natural logical step, is to have a moving robot.
Right.
So that I had been working on that for a few years, trying to get the code figured out. Couldn't figure it out until I met you, and then we just hammered at it.
Yeah, that's right.
So
let me segue from that to, there's we met at a workshop. I'm going to share my screen briefly.
Sure.
And let's see, share my screen. Yeah, this picture tells a big story. This was the workshop you described where you came. We led a program workshop. You can see you working with a colleague, a professor from UC Berkeley named Lynette Jimerson. It's worth noting that Lynette teaches in the humanities. She oversees the English Pathway program at UC Berkeley's Graduate School of Ed, and she's dedicated to innovation and equity and literacy. And she took it upon herself, along with some of her students, to sort of learn what the possibilities were for literacy and documentation using these new materials. And that's such a lovely picture of you, the two of you working, and you teaching and learning. And it was such an inspiration in terms of where this might go. One thing I like about this photograph, and I've used it in different places, because the amount of touch points that each of you and Lynette, have had with colleagues is pretty profound. And from our perspective, the ability for people to learn this material and then to take it out and share it is quite meaningful. Could you talk a little bit, Jeannine, about the people you've worked with around these materials? Because
yes,
this is really what we get up in the morning to do, which is to find people who absorb the practice, explore the materials, and then extend it in their own settings with their own colleagues in their own situations. Can you talk a little bit about where you've gone with this on your own? Then we'll come back to the booklet and we'll go through what you did to get us through book 4.
Yeah. So with my students, I was teaching at the Da Vinci Center inside of Teachers College. And we have windows all across the front of the classroom, in front of all the classrooms, and people can come and meet in the center. And so we had a lot of visitors, 2-3 tours a day. Apple, goodness, I'm trying to think of some of the other people that have been out. And they would go through our different labs and see this full engineering academy, media, robotics, pre-engineering, graphic arts, things like that. And so we were always giving tours, and then people would ask us, how do you do this? And teachers who would come to the classrooms at night would see all of our projects and our place. They would always take tours through our projects in our place. In fact, I did when I was the first intern as well. So they'd get excited and they'd contact me and they'd want me to teach them how to do this. And so as I learned things, I would add those things and say, well, this is where you start, this is where you go next, and from there. And so I started doing some workshops of our own, and I've done paper circuitry workshops as well. And then I've done the SparkFun AT Tiny one using the Program Your Pages. That's just been a real favorite. And it's so fun because you hardly get started with the teachers and they take off and they're making their names in Morse code or making their lights blink, and they're, just seeing the excitement. There's a little bit of you have to build on one skill to another skill. And so that's been a lot of fun. And, I was invited by you and AK Teach to go up to Alaska. And the closer we got to that conference, you and I got silly crazy about, let's teach them more than we had agreed to teach. So we went up there with all of these resistors, capacitors, regulators, and LEDs, breadboards, and wire, all this stuff you got sent up there. We brought servos, and then we just had this fabulous time creating with the teachers, making our own test boards, and that's that one that I took up there. But the one we ran into an engineering problem, and the teachers using the smaller breadboard, and so they came away with skills that we hadn't even intended to teach, and we all taught ourselves together how to do something well, I want to say fun, because we ended up learning how to use all these simple parts, and we ended up with an engineering kit, really, of individuals. So now instead of wondering, well, okay, how does this Arduino work? We kind of made our own Arduinos. We made our own microprocessors, our own regulators. So that was kind of the pinnacle of our experience. And I know you and we just jettisoned on, I think, on our learning even more from when that teachers are hungry to learn. Which was what I really enjoyed about this whole process. So it's gone from there.
Yeah, let me share a few of those photographs. I'm going to hit my screen share again. So this is an interesting picture that speaks to where we started. And I'm going to jump backwards a leave in a little bit to, let's see if I can find it here. There it is. When we started this work and we were looking at the revising and extending the first two booklets that we did in 2014 to include servos and pop-up. And we had hoped to do sound as well, and I think that's the next one we're going to do. But as we were going through this, we connected with a really wonderful advisor, colleague, friend, learning designer named Dr. Sherry Shi, who's done a ton of really great work in the paper mechatronics world. And is trained as a mechanical engineer and is a really brilliant learning designer and community person. Really, really lovely person, smart woman. And we were talking about the design cycle and how we'd revise it. And you and Sherry had proposed that we actually revisit what we were doing. Jennifer and I, when we first started, you can see these words down here, we put in our little booklets, the last third of each booklet includes kind of a storyboard of how the project might work. And we called it Connect, Collaborate, Present, and Connect. And you and Sherry had some good comments about trying to make the sequence a little more aligned with what we might think of as a formal engineering or iteration cycle. And this was the beginning of that discussion. And I just want to share it a little bit because it does speak to some of the design things we did with partners. You can see where we wound up, and the booklets that are going to go out in the Kickstarter now include the 4 stages, which are modified to reflect these pair of these verbs. You can never get enough verbs here. So we now have a 4-part sequence in our design cycle. It has imagine and collaborate, design and create, test and share, revise and reflect. And you can sort of see the way, and we'll talk a little bit about this with Chamisa, but we've been through the drawings and the illustrations and the collaboration work that's happened with all of the participants and the creators and the authors here is really, really great. There's just been a ton of work spent on how we have iterated our way through this stuff. And then we landed on this one. Mm-hmm. And you can see why we would land there for all the reasons with the golden rule and the Fibonacci spiral. And so here we are. This is you and Sherry really helped us think this through, and we made our way through to what I think is a really great, evocative, really nice image about the project cycle. So that was really, it's a big piece of where we are in terms of what it means to collaborate. And this kind of conversation led us directly into this iteration that we did together. Can you talk a little bit about this image, Jeannine? This is a prototypical workbench sketch. There are a whole host of things going on here, but this really speaks to some of your design, some of the design process you went through to get us to automate your ideas. Do you want to talk a little bit about it?
Yes, I'm just going to look at my notes real quick, pull up. There's, in working with Dr. She had an idea with the paper mechatronics. She wanted to, she's working on the idea of adding sound or sensors, because when a real robot, according to Dr. Bach, has sensors, not only moves, but it's capable of doing so many different types of tests. So Dr. She's idea was that she would love to create some sort of a panda robot that has a sensor built in that can detect pollution. And we would create some sort of a story that would help the different nations that still use a lot of coal burning for energy, as maybe let's look at other alternative solutions, because look what it's doing to our environment and to our flora. And so I thought about that, and I thought, well, I'm just going to put together a quick prototype. And I had all the ideas. We already had the servo code working for breadboards. We could do that easily enough with the AT Tiny. And then I just thought, gosh, it would just be so wonderful to somehow make it so that the panda could be inside the notebook and flip up somehow. And so I put together that prototype that you were looking at. And I had to think of, well, I'm going to have to strip the wires, solder them down. Later, we thought about we could connect them, disconnect them, use the servo elsewhere. And all it was meant to be was a quick prototype that you could lay flat, put it in a little pocket in your notebook, and a quick design so we could put together our workshop for Alaska. Yep. And they could color it as a panda or not. They could any color really, and so that's what that was about.
Yeah, this is great. Thank you so much for walking us through that. That whole business of the panda, that grew out of the Open Data, Open Minds work, which is where all this Hack Your Notebook prototyping and these booklets are headed, which is to be able to pull live signal from the web into our papercraft projects and create a really connected project that allows us to have discussions about civic engagement and our communities. And so the idea of air pollution in China or the quality of the air in Pittsburgh are conversations that are equivalent in terms of the data specifications on AQI and so forth. And so the robot is really a figure, right? You can design it to do with the armature to do whatever you like. It's a beautiful little flat pack. So I'm going to switch the photograph. We're going to jump now down to, can you see this image now, Jeannine?
Yes.
Yeah, this was, so we decided to sort of work our way through. You can see in the upper left of that image, this panda prototype robot. And we've stuck with that. The whole point is that, it's not just a panda. You could do any kind of figure or any sort of armature where there's some motion. It's a very simple servo project, but it's quite evocative, right? And this is, do you want to talk a little bit about the lower right photograph, Jeannine? Because we were very intentional in trying to create a scaffold going through the number of lights one would use and so forth. And you did a great job of documenting that on your Weebly. And you want to speak a little bit about that?
Yes, using G's idea and your tutorials from one LED hooked up to an AT Tiny, the next thing is, well, how do I do 2? How do I do 3? How do I do 4? And what does that look like? And we want the children or the adults to experience trying to figure that out themselves. And by the time they've added a second LED, we really don't need to show them the code. The code's there for you to go compare yours and go, is there something I'm missing, a semicolon? And so we created a series of lessons that just took you all the way up to 5 LEDs that you could program, because the AT Tiny has that many ports that you can use. And so you can tell a story with the different programs that you create. And from there, we were able to take the adults to adding the servo at that point. So once they had learned how to do this, and I'm just going to show you this one picture real quickly while you're doing that. Pull that up. This guy. Of course, they're not right in plain sight. I'm just thumbing through my notebook quickly it's past all of those because it just takes, this is one I've shown before. It's documented. It goes from the SOS, and that was programmed just using 3 of the pins on the AT Tiny. So it just shows the amount of complexity that you can create, or that students can create.
Yeah, absolutely. I've just moved up to another photograph of us, of the session we did in Alaska together. Can you see that?
Yeah.
And this is another little collage here where you can see in the lower left the circuit trace layout for the AT Tiny with 4 different lights. We've got a little insulator there where you can see the copper tape is bridging. Some beautiful tape work by that teacher. I think that was the same instructor or teacher who did the butterfly above. I've been tweeting this stuff out, and we'll repost it up on Twitter. But this was a lovely combination of circuit traces, the technical elements of the code, and the circuit sketch. That test board that you introduced everyone to, and you can see the folks in the lower right there sitting around kind of in a group way. All of us built our own little, miniature breadboards for testing the circuit, which is, the AT Tiny, the AVR, has one little LED. So if you've got multiple LEDs in your circuit system, the breadboard you created allowed us to see the actual sequence of them in rotation, or whatever the sequence was. Do you want to explain a little bit about what that is for folks who might not know?
Yes. So the AT Tiny is, of course, it's just its own little, little microprocessor, that little guy that we're using, and here's the programmer, our little breadboards. And with this little test board, you can create a different pattern with each of the LEDs. And when you look at the beautiful butterfly design that the teacher made, because this was a teacher academy in Alaska, she had to then, after she had learned the simple 1, 2, 3, 4, or 5 LEDs, she had to design her own traces. How is she going to pull the circuit stickers on over to underneath her design? And so some of the teachers wanted to design something beautiful first, like that. It's just so exotic. And then they had to figure out, how will I light it? How will I do that? And once you move away from using a pattern and you create your own design, it's very liberating. And then you think of all the other things. Well, I can pull them here. I can pull them up over there. And that's the genesis of what you could see in G's dandelion painting, because she not only used the tiny 84s, I think those are the 16 pins, she used them all over the place, and she learned to chain them together, and that's what we were doing up here in Alaska as well. Different combinations that the teachers experimented with, they kept bouncing their ideas off of each other. That was so exciting. You and I would look at each other, we would see something, and we would just go, oh my goodness. It was, so the teacher development aspect of it was was just incredible because they leapfrogged off the pages and were ready to go back and teach and could do everything on their own at that point in time.
Yeah, that's it. The this photograph, this little collage, you can see at the top from left to right. There's you can see she used kind of little gels that she cut out of the paper, and you can see the sort of the patches sort of pasted onto the back side of that notebook page over on the right image, and it folds over on top of those 3 LEDs. So the whole business of sort of deconstructing small, expressive engineering and visualization systems really is what this is, and doing it with familiar materials in an accessible and delightful and pretty funky way, and a very evocative way is really the whole point. You think in the big picture of how all of our tech is black box, so to speak. It's a closed engineering system. It's a closed piece of hardware typically, and these projects allow us to take them apart a little bit and build them from the bottom up. So that's really where we're at with what we're trying to do with this. So Jeannine, in wrap up, one of the questions we wanted to ask folks was, what's the impact of this work mean for you, and where do you want to see it go? We're putting this work out into the world. It's not a straight path. It's designed to give people a springboard and let them improvise and let them adapt and absorb it. And you have your own version of that. We've heard some of that today. So I'm curious what your thoughts are.
In research, in my research, my doctoral research, I really thought back about how hard it was for me to learn to do these things myself. And if we're going to really reach our kids and improve our society, we need to learn how to teach complicated technology to our students. But the teachers don't have any way of learning how to do it. Engineers almost are born engineering. But if you're a teacher of English like you or me, I taught English. And as I was saying earlier, I was a self-contained 8th grade classroom and taught all 4 subjects. And we wove in art. We started to do some engineering of wind turbines and things like that. And we need to know how things, we need to understand things first. So I looked for somebody that was not an engineer, and that was Kate Hodges. And she's her own beautiful story that we can bring in. And she discovered paper circuitry. She created a Frankenstein unit where the students had to create an invention using paper circuitry. And the impact that it had on her, the impact that it had on the students, was this confidence, this great building confidence. I can do this. And I never thought I could do it before. That's how I felt. And so the teachers that you and I have worked with, when we've advanced them into this advanced engineering, we see that happen. Their confidence within a day, they're taking off. And I don't know how to do this. Now I know how to do this. And they start thinking, it branches off into other ideas that they have coming through their head, and looking at what the other person did, and oh, I want to try that. And we documented that rather well. So this can be used to layer engineering into any discipline, any teaching. And it's the notebook idea that I just love, and the portability. They go home, the student goes home, the teacher goes home with a set of notebooks, and it shows them how they did it, and they can turn around and recreate it again, and turn around and teach it, and think, how will I incorporate this into my other subjects? Like you said, open data, open minds. So that's it.
That's great. That's great. Thank you so much, Jeannine. Well, this is the first of 5 or 6 that we're going to do. It's been great to see you and talk together.
Again.
Yeah, again. So I'm looking forward to more of this. Once these booklets go out, during the time that we were going to and from Alaska, we did distance learning, sort of Zoom and Blue Jeans meetups, and who knows? I think what we may try to do after the Hack Your Notebook project ship is to reconvene some people and see if we can get that restarted.
Absolutely.
So we'll find a way to reconnect. So thank you, Jeannine.
It's good talking to you again.
It absolutely is. And we'll be in touch. Okay. Bye-bye.
Bye.